Hello, I'd like to do a simple statistical problem today to find the average mass of a cube in this population of 500 cubes. And rather than measure the mass of each one and divide by 500, sum them up and divide by 500, I'm going to take a sample of 10 cubes, weigh each one of them, and then do the statistics to determine the estimate of the average mass and the 95% confidence limits. So let's get to it. Okay, let's go over a few of the equations that we'll be using in this analysis. I'm sure you're all familiar with the mean, x bar. So we have 10 masses of cubes. We sum up each of the 10, sum over the 10 values, divide by 10 to get the average. Everybody's familiar with that. The variance, we take each individual value minus the average and square it, sum that up, all 10 differences squared, and divide by what's called the degrees of freedom, which is, in this case, 10 minus 1, or 9. And the symbol for the variance is s squared. Another important quantity is the standard deviation, which is simply the square root of the variance. All right, now we want the 95% confidence limit. So we want the average and its range of values that we have 95% confidence that the mean of the population is in that range. Okay, and here's the formula. So x bar is the average. T is part of something called the t-distribution. We'll talk about that in a second. Now in this case, alpha is 0.05. 95% corresponds to 0.05 outside that range. Divide it by 2 because there's 2 tails. Okay, so that's the t with a 0.025 value, and n minus 1 is the degrees of freedom. That's 9 in this case. So this t value is part of the t-distribution, all right? So if we take t times the standard error, which is the standard deviation of the square root of n, all right? This quantity, by the way, the standard error, tells us how varied our range of values would be. If we did this experiment with 10 trials over and over again, there'd be a bell-shaped curve, and the width of that curve is related to this standard error. And you can see the standard error gets smaller as we have more values that we in our sample. We have 10 in this case. If we did 20, it would be smaller. All right. Okay, so let's look at the t-distribution. Remember, the t times s over the square root of n tells us what the confidence limits are. This is the t-distribution. It's a bell-shaped curve, but not a normal distribution. It's a little bit lower in the center, and it has bigger tails. So this is the t-distribution. Okay, sorry about that. I got a phone call, but here's the t-distribution. And as I said, it's a little bit shallower in the center and wider on the wings. But the t-value for a 95% confidence, alpha being 0.05, is 2.262. Okay, so if we take that t-value and multiply by the standard deviation over the square root of n, we will get the confidence limits, and we can add them and subtract them from the mean to get the confidence range. Okay, let's go on to look at the data. Okay, we're finally ready to look at our data and work it up. Again, we're trying to get the average mass, an estimate of the average mass of a cube in this container of 500 cubes. That's the population. So we're taking a sample of 10 cubes, measuring their individual masses. So those are the x sub i's, the individual masses. So we have a count of 10, and we calculate the mean in the usual way, sum up the values and divide by 10. And that's what we get, 1.0235 as our mean. Now, we're going to calculate the variance because we need that to get the confidence limit. And again, it's the difference between the individual values and the average squared. So those are the individual differences squared. add them up and divide by n minus 1, which is 9. That's the variance. There's our formula there from Excel. So that's s squared. The standard error is given here, and it's the square root. It's the standard deviation, which is the square root of s squared divided by the square root of n, which is 10. Okay, so that's our standard error, 0.0023, and we multiply by the t value, which we get, this is the formula from Excel to get it, t dot inverse dot 2t means two tails. Our confidence limit is 0.05, we're excluding 0.05 of the values, and the degrees of freedom is 9, all right? All right, and so we multiply that value by the standard error to get the confidence limits. And if we add those to the mean, we get the high range, and subtract that from the mean, we get the low range. So this here are a range of values for our estimate of the population mean. It's going to be somewhere to 95% confidence between 1.0183 and 1.0287. Just a few words. We can do this in an easier way using Excel. Take the values, get the count, get the mean, get the standard deviation, and you can calculate the standard, the confidence limits directly using this formula here, confidence.t, and we have the 0.05 as our confidence limits. This value here is the standard deviation, so you have to enter that, and you have to enter the count, all right? And again, we get the exact same value. So in summary, we've determined the mean and the confidence limit for this set of data. And I hope you enjoyed that and you understand it. Thank you for your attention. I'll see you next time.